Welcome, sir.
Welcome, ma.
Welcome, sir.
Uh, Anisha, ma'am, can you
Yeah,
introduce our resource person?
yeah, ma'am, sure. Once again, an energized evening and a very warm welcome to our resource person, Engineer Ashok Seduraman, sir, and all the participants for the sixth session of third day of ATAL FDP program. It gives me great pleasure to introduce our esteemed resource person, Seduraman, sir. He holds a BTech from MIT and is a BEE accredited energy auditor, recognized by the Bureau of Energy Efficiency, Ministry of Power, Government of India. With over 45 years of industrial experience in India and abroad, he has successfully conducted more than 800 energy audits across various industries. He is also a well-known speaker, having delivered lectures in numerous industrial seminars organized by BEE, PCRA, SIMA, SIEMA, and ISHRAC, and many engineering colleges across the country. He is also an author of several insightful books, including Practical Guide to Energy Conservation and Management and Energy Conservation in Textile Mills. His articles and lectures are widely appreciated, and many of his sessions are available on his knowledge sharing portal, energymeasuredtosave.com, and his YouTube channel, Energy Measured to Save. Today, he is going to enlighten us in the topic of a pathway to combat climate change, energy efficiency in industries and buildings. I once again welcome Ashok Seduraman, sir. Sir, the screen is yours.
Thank you, ma. Thank you. Respected staff and respected audience, I thank you for giving this opportunity. Am I audible, ma'am? Just want to know.
Yes, sir. Yeah.
Okay. I'm just sharing my screen. Is it visible, ma?
Is it visible, sir?
Yeah.
Please keep it in full screen mode.
Yeah. In fact, I am trying to put it in full screen mode only.
Okay.
But am I? Are you able to see my slide as such in the normal mode?
Yeah, yes, sir.
Okay.
Control F5, sir, you control F5. Or in slideshow,
Yeah.
also you can use it, sir.
Okay. My slide is moving as such.
Not moving, sir.
Not moving.
It is in the first slide.
Okay.
Sir, I think you have shared the PPT but not the presentation, sir.
Okay. 1 second. 1 second. I will just come out. And, now, is it visible now? Is it visible now?
No,
Yes, sir.
still we are seeing that presentation only, sir. I mean, not in the slideshow mode.
Shall I just come out and then come back again? 1 second.
Okay, sir.
Now we can see PDF, sir.
Okay. It is moving as it?
Yes.
Yeah, okay. Shall I go ahead as it?
Sir, otherwise you can put in the slide that is slideshow.
Yeah, in fact, I
So
am
in the
putting.
PPT, in the top, there is a icon slideshow. If you click it, it shows from beginning, from current slide, like that, sir. You can
Yeah.
click from beginning.
Okay, this is my beginning first slide only.
From beginning.
Yeah.
I think it is a PDF format, sir.
It is in PDF format.
It's a PDF format. If you go to
Now
the
you are sharing
PPT.
PDF, sir.
Okay. I think I will go to PPT as it, isn't it?
Yes, sir. Yes, sir. In the
Yes.
PPT, it will be
Sir,
slideshow.
one suggestion, you stop the screen share and then do the presentation, I mean, in a slideshow mode, and then reshare only slideshow, sir. That will solve the problem.
Okay. Now, is it visible now? First, it is
No,
in
still
slideshow.
we are seeing the PDF, sir.
Sir, you can stop
Sir,
this PDF, sir.
Okay.
Stop sharing.
1 second.
ma'am, otherwise, shall we share the slides?
Sir, can we share your slides?
Yeah. I'll just
Yes.
try once more.
Okay, okay, sir.
Yeah.
Yes, sir.
Yeah.
In this, you can select slideshow.
Okay.
Yes, sir. Yes, sir.
My slides are moving as it.
Yes, yes, it's moving.
Okay. 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 Sorry for the inconvenience. Sorry.
No problem, sir.
No issues.
Yeah, okay. Thank you all for giving this opportunity to share my thought process, especially on the energy conservation management. This is a pathway towards combating the climate change and the energy efficiency in buildings. I am just in two topics. One is buildings and the other one is on the industries. We will just go in depth where all the case studies and what are all possible by the institution, by the industry, and by the buildings. We will just discuss in length in coming slides. In India, our the building segment is the third major energy guzzler here. As such, the consumption of energy is going up, especially in the commercial segments, and at the rate of almost when the construction industry is going at the rate of growing at the rate of 10%, and almost 1 billion meter squared of commercial building is going to be added each and every decade, and they are going to have the largest consumer of electricity, especially the energy means the electricity and the other sources, but basically the major portion of the buildings they consume more of the electricity. Then comes the diesel towards the standby usage and the LPG usage, especially for the residential buildings. Here, I would like to just emphasize what our beloved past President Dr. Abdul Kalam used to say. The energy conservation and management, especially why it is important at the moment for the country like us, because throughout the world the energy prices have shot up like anything, and still we are not able to, we are giving a lot of subsidy to the domestic people as well as to the industries, whereas if you visit the coal mine and you see the how hardly it is the energy is generated in the thermal stations and especially in the coal mines, because coal is again a base load for us, that is the major consumption, that is the major way of producing the electricity towards our Indian electricity distribution as such. So the cost of 1 megawatt, it may be many crores, it may be 4 or 5 crores, say for a solar rooftop means it is around 4 crores, for a windmill it is again 6 to 7 crores, and again for a thermal station, super thermal station, say 500 megawatt means almost you have to invest around 2500 to 3000 crores. Whereas this energy conservation, whatever 1 megawatt solar rooftop is going to give it to us, the same 5000 units per day is recoverable, or it can be reduced by energy conservation. And the cost, in fact, where we have done almost these energy audits in many of the industries, where they have done the solar rooftop and then they have done the energy audit, they said we have almost spent almost 5 crores for this 1 megawatt solar, but we are able to retrieve that, reduce our energy consumption by 5,000 to 5,000 units per day by just spending around 80 lakhs, less than 1 crore only. So this is where the energy conservation gains the priority, especially in the industry, and it is almost very much applicable to the institutions as well as such. So if you see the energy conservation possibilities, especially on the commercial buildings and on the residential buildings, almost the new buildings, 25 to 35% is there, thanks to the ECBC code, Energy Conservation Building Code by the Government of India, Bureau of Energy Efficiency. They give an entire in-depth analysis of what are all the possible energy conservation measures or the energy efficiency measures that can be implemented in each and every new commercial building. And if it is an existing commercial building, minimum around 15% is possible. The energy efficiency upgrades, in the case of, see, the star rating, it is not only applied for the domestic side, it can be applied to the commercial side also. It is applied to the HVAC side also, because HVAC, this heating, vacuum and air conditioning, this consumes almost 50% of the building cost, especially on the commercial buildings. And residential buildings also, they are towing in line. There, say, the people who are using the ceiling fans, now many of the people have started switching over to the air conditioners, and the air conditioners which was consuming almost 2 kilowatts per ton, they have come down to 1 kilowatt per ton thanks to the inverter mode of operation, and lot of inputs are coming to the domestic segment also from the industry side. So especially on the residential segment, it is not only on the appliance efficiency but the passive design features of the residential buildings. That is one aspect. The other aspect is almost 20% the energy saving potential is possible. It is only one is the energy appliance efficiency and the way of operation, and how the practices is done so as to control or conserve the electricity as such. So energy conservation or the consumption, it is not only dependent on the type of the building, it has to be efficiently designed and constructed, and also the interior gadgets which are used. See, this is more important. Say the old, for example, if you see some of the old buildings, almost 10 feet or 11 feet or 12 feet, almost 14 feet. In some of the educational institutions, some decade old education institutions, we have seen the ceiling is at almost 15 feet. So you can see the attic ventilation is more in that building, and the building is always cool inside. And now coming to the latest commercial buildings or the residential buildings, how it can be efficiently designed and constructed so that the lighting and ventilation can be improved on existing system. This is more important. The lighting arrangements or the lighting accessories, the lighting system and the luminous efficacy part of the lighting circuit. This is more important for the users in the premises as such. And the system of air conditioning. It can be a water cooled system in the daytime usage, and it can be an air cooled system in the night time usage. That is, we are tropically placed in India, where we can make use of the ambient wet bulb, and in such a way that we can make use of the water cooled air conditioners packages, especially in the, not only I am talking not about the split AC or the small ACs, but I am talking about the packages around 100 tons or 200 tons or 1000 tons. Normally many of the commercial buildings, they have started using the water cooled versions, or the adiabatic version of air conditioning, and then comes the air cooled version in the night time. See, just to manage the daytime and night time operations as such. The cooling and the ambient temperature, wet bulb temperature matters more, especially in the air conditioning usage. That is made use of here as such. So if you basically see the energy balance of any given building, let us say it is a IT park building, or it is a commercial building, or it is a hospitality building, the chiller load is almost around 50%, and the EB distribution is whatever it may be there. The UPS is needed very much for some of the sophisticated equipments, and for the computers and all the other sophisticated, where you cannot have a downtime as such. And the air handling units, these air handling units, this is where I am focusing more now, because Normally, we are understanding a part of climate. The pathway to climate change, especially in India, it can happen only by more of air circulation than of air conditioning. I will just repeat it again. If you concentrate more on the air circulation, definitely the air conditioning can be optimized. I will just go in depth in many of my slides, case studies. This is where we wanted to utilize the air circulation, what is inside the premises, how the fresh air can be put inside the premises. This is a part of ECBC scheme where the government mandates the fresh air provision has to be there in any of the, say, IT building or a hospital building. The fresh air mandatory provision that needs to be maintained so that the indoor air quality. Ultimately, we boil down to the indoor air quality for a given building where that needs to be maintained, and at the same time the CO2 or the CO, what is the present in the existing premises, that also needs to be maintained. If that is going to be more beyond the limits, that will sicken the occupants in the premises. This is where we are concentrating more. Then comes the lighting, but thanks to the latest innovations in the lighting, LED circuits and all the more of LED illuminations, and we can see the positives of the LED is it can have an excellent, the luminous depreciation is very less when it is used for more than, say, normally people give it for more than, say, 5 years and 10. Before we had this fluorescent lamp or the CFL, which was dimming within the first 1000 hours, and within 3000 hours it gets diminished. Whereas for a LED, almost for 30,000 hours, the ISI rated LED bulbs and tubes are available. And now, previously the industry or even the college establishment, they went for a 15 watt LED, but that is not enough. They understood. Many people now, the industry, the lighting industry itself, they stopped producing this 15 watts or 16 watts. They are now producing only 20 watts. And they also stated that the ultrasonic impact on the LED emission is curtailed and it is made controlled. And ultimately, you can see the previously the raw type LED architecture and what is the latest LED architecture. You can see the difference. You can see the comfort level. Then comes the chilled water pumps. I will also take in depth. See, EEE means not the electrical and electronics only. Any system, whatever may be the prime mover, either it is an electronic or a motor, electric motor, or whatever may be the prime mover, the load side decides the energy consumption, and there is a scope. See, if it is 100% the consumption is there, almost the 3/4 of the energy savings can be achieved towards the load side, only 1/4 towards can be achieved in the prime mover side. Then comes the LPG, which is used in the commercial buildings as well as in the domestic side. There also the lot of changes are happening now as such. Again, this 2017 and 18, this ECBC code by the Bureau of Energy Efficiency, it gave lot of inputs. See, they have clearly demarcated what is the EPI, the energy performance indicator for a given building, and what is the EPI ratio for the proposed building to the existing standard building. The EPI ratio decides if this is applicable to institutions like our colleges, applicable to any of the IT buildings, any of the commercial buildings, any of the hospitality buildings, and even in the residential buildings where the gated community buildings are coming in. So the annual energy consumption in kilowatt units, kWh units by the total built up area. Here the unconditioned basement, see, the basement area is where the cars are getting parked, and that is excluded, and the total, divided by the total area automatically gives the energy performance indicator for a given building. This is what is the benchmark for each and every building. And when we do the energy audits, in fact, from the colleges also we can do lot of energy audits. We can do the energy studies, we can do a walkthrough audits, we can do a energy survey as such, and see where all the energy consumption is happening and how this can be optimized, how this can be reduced or controlled. So the standard building versus the proposed building as per the ECBC, Energy Efficiency Building Code, what is the difference and how it can be achieved on? We will go in depth as such. If you see the government norms, it starts from 100 kilowatt for a public utility building, and say many of the buildings they are mandated to have the energy audit to be done. That is why the building energy auditors have come into play now, and it is in force now. Many of the college staff and the professors, they also opt for this. One is industry based energy audits, they also take the building based energy audits, and we have an ample scope because the third major energy guzzler is the buildings. One is commercial, this not only the hospitals, not only the IT parks, many of the office buildings, it is a bank or an insurance or any of the this one where the public utility buildings are there, they are supposed to have done the energy audit and started reducing their consumption for the sustainability. Ultimately, we are all working towards the ESG. This is where every colleges or every the building owners, they are made reasonable or they are made responsible for their energy consumption, and they are made responsible to reduce their energy consumption also. So sorry, so the office buildings, the hotels, hospitals, retail malls and IT parks, this comes under the 4 climate zones of across the country. Apart from it, the climate zones, these are also is varying climate zone. One is warm and humid, and the other one is composite, other one is hot and dry. A place like Rajasthan or anywhere, you can see the hot and dry climate. A place like Chennai, where it is warm and humid, and somewhere it is composite also in some of the internal areas. So these are all the areas the EPA of the building is studied, and with respect to the zone, climatic zone of the building where it is installed or where it is located, this also matters for towards the EPA as such. I am just taking a case study why the energy performance indicator for a given building is varying due to envelope optimization. Envelope means the building envelope optimization, then the lighting optimization, then the HVAC optimization, then the controls. Controls means now the trend is, previously the buildings they had only a BMS. Now BMS is in building energy management system is incorporated into the BMS system, and ultimately the goal of the given building is to reduce their consumption, and they have the benchmark, and based on the benchmark how much they are able to reduce it. This is a computer building only at IIT Kanpur. The case study shows that almost from 240 units to 200 units, the envelope optimization. How this can be done, I will go in next few slides. And the lighting optimization also. But the lighting optimization, now lot of the daytime lighting and the light pipe and all this polycarbonate lighting, that also is coming to play, where you need to have the light that is getting distributed equally among the inside the premises. That is more important. See, some of the LED application where it is getting localized, whereas some of the LED which needs to be the lighting design of the luminous application of the design is done, means the distribution needs to be smooth, scattered and diffused. It needs to be diffused inside the premises. That is what we are concentrating more now. Then the HVAC optimization, this is where previous HVAC, all this 100 tonner or 200 tonner or 500 tonner, they were all operating almost around 1.5 to 2 kilowatt per ton. But thanks to lot of innovations happening in the HVAC, and it is coming down to 1 kilowatt per ton, and somewhere it is around 0.75 kilowatt per ton, and we are the major green buildings are all aiming for almost 0.5 kilowatt per ton. So this is where what can be done to the existing HVAC to retrofit to reduce their consumption. That is one aspect. And in case if it is not possible, it is a decade old HVAC system package that needs to be replaced. See, what are all possible energy savings is possible in a given system, it is possible. A system which is having a defect of its own, whatever the energy saving is possible, it can be done. A system which is not having the defect, the energy saving is possible. But a system with an inherent defect in the system, you cannot do anything, but you have to replace it only with an energy efficient systems. That we will go in depth as such. So the controls, see, whatever the energy efficient appliance or an equipment or any machine, what we buy for the building or what we buy for the industry, buying an energy efficient equipment is half done, whereas operating the energy efficient equipment in an energy efficient way, where the loading is there, where the controls are there, how this can be optimized. This is where it plays more as such now. So you can see the windows, roof, skylights, doors, openings, the design features. See, the building envelope, where what we are seeing is the visual and thermal comfort of the occupants. This is more important to achieve the building envelope, and the building envelope takes care of the both the visual comfort as well as the thermal comfort of the occupants. This is where it is concentrated by the architects as well as the energy auditors, energy professionals who can work together along with the architects and make the building envelope efficient than the existing one. Then comes the mechanical systems and equipments. These mechanical systems means I am trying to say it is a air conditioner. It may be a split. The window air conditioner is gone. It's out. It has gone totally obsolete. The split air conditioner or a package air conditioner or a ducted split or a package or a multi-tunner package. All these things, this comes in the next line. Then the interior and exterior lighting, thanks to the daylighting, more of daylighting provision is there. Many of the IT officers, they have understood the daylighting has to be there from the sunlight only. Many people have understood because from the lighting from the sun is almost 600 lumens per meter squared, means whatever you get from the 4 feet LED tube light or anything is around 100 to 105 or 110 lumens per meter squared only. So the solar lighting is given the priority, especially in buildings. Many of the buildings and many of the colleges, they have a dome where you can see the solar lighting is definitely coming inside as a light pipe, and definitely it is made use of it inside. The electrical power motors and renewable energy systems, these are all going for a ST service for a given building, let us say for the college, or if it is for a IT building, energy efficient transformers based on the standards 1180, this level 1, level 2, level 3. See, the transformers are also, they are basically passive, but still their self loss is more. The previous transformers, the decoupled transformers, they were not operated as OLTC, on-load tap changeover was not there. But now on-load tap changer is becoming mandatory, and some of the buildings where they have some of the sophisticated machines and all, they even prefer a servo stabilizer, which the voltage correction rate in a servo stabilizer, almost it is 30 volts per second it can happen. Or in even some of the buildings where they have more sophisticated equipments inside, they go for thyristor based servo stabilizer, where they talk in terms of voltage correction rate in the terms of milliseconds as such. It depends upon the usage, where we use and how we use, because none of the distribution transformers supplied by the EB, they don't have any on-load tap changer provision. They have only off-load tap changer only, and whatever the at the tail end the voltage drops to 380 only, and at the feed end near the transformer end it's almost 440 plus only. If we want to have a control of our own building, or if we have to say, let us say it is a college near a substation, means definitely you need to have a OLTC in the transformer in your building and keep to the maximum reduced setting in such a way that you always get only around 400 volts. In this case, I will just go in depth, especially in the industry side. Lighting provision, lighting circuit, it can a safe operating voltage. See, these are all. I always give my respect to the college professors. What all we talk, what all we study in the books, and what all we see in the industry, there is some basic difference. The practical differences. We go by the thumb rules. What all the lighting circuits we have on the single phase systems, it is 200 volts plus or minus 10 volts. That is more or less enough. It's because a lot of LED lights have already taken over. The LED lighting has already taken over totally. Though they say it is from 170 to 270, but when I am operating the same LED circuit at 200 volt, I am getting saving. I am getting the luminous depreciation level that does not drop faster. If you keep a same LED at 240 volt, the luminous depreciation level is more. If they keep the LED at for 200 volts, say for 5 years, the depreciation level is very much minimum. This is where we are concentrating more. And for the motors, any of the motors in India or abroad, I am talking about the 50 hertz cycle only. 400 volts. See, 400 volts for a given motor supplied to the motor terminals. That definitely, because see, any of the industries, if you take almost say, let us say 1000 motors are there in a given industry, almost 800 more 900 motors, they are operating around 70% or 80% only. Very few motors are operating at 100%, And normally the motor is also rated for 380 to 420, means it's around 400 volts for the given motor, it is fine. So these are all the areas which we concentrate on the industries. But the power factor controls, this is again whatever said and done in theory, a motor is a balanced three-phase load in practice, in theory, but practically it is not happening. Definitely the neutral current is there, the negative phase sequence currents are already there, and definitely in the industry, see what I am giving the inputs or the case studies is from the industry. So definitely a 3CT operated power factor control for a given building for any LT service or a ST service is mandatory. Why I am telling this now is, many of the industries, they have gone for only single CT. They assume all the CTs are giving the same current. Definitely in a harmonic loads where H5 and H7 components are there, definitely the unbalance of current is very much more. You cannot control the power factor with just one CT sensing. It needs to be done with 3 CT only as such. Coming to the thermal side of the building, thermal comfort of the building, what is the heat loss comparison? If you see the U factor, I'll just go in depth on the U factor also. See, we have seen a single glazing window, double glazing window. Almost many of the modern buildings, green buildings, they go for double glazing window, so that they see to it that the heat loss is minimum across the windows. See, the windows are the areas where so much of not only the light but the heat ingress is there from the sun to the inside. This can be arrested only if you go for a double glazing tiles, especially in the windows. The light from the sun passes through the room and cooler in the room. You can see the glass with coating. See, on the one is going for a double glazed tile, all the glass with coating. This is a retrofit that has come. See, for any of the replacement what we are suggesting for the industry, there is a retrofit also is possible. So first let us try for the retrofit. If it doesn't work out, and if it I don't say it doesn't work out, if the effect of the retrofit is less over the getting derated, definitely it is better to go for a replacement, especially for the double glazed tiles as such. Especially you can see the outside visible light and the solar radiation. These are all the areas where we can they are relevant to the daylight harvesting basically. See, for a EEE department, why I am talking about the industries or the buildings thermal side, because the thermal side of the building only decides the energy consumption for the given building. The heat ingress, the solar heat ingress for the given building is very much more. So definitely that needs to be controlled. So this is where the visible light and the solar radiation, and how this can be the U value. Ultimately the U value is notes the conduction of heat gain through the glazing unit. This is where the lower the U value, automatically it is better for us as such. This is the three-tier approach what the Bureau of Energy Efficiency all through the ECBC code have suggested to all the building owners. First, the heat avoidance. You take the why even in our Chennai or in Telangana, the government has made, see, not in Chennai but in Telangana, the government has mandated to have only the white roofs to avoid the heat avoidance. Then comes the passive cooling, where the attic ventilation can be improved upon. Then comes the mechanical cooling, the tier 3 approach, where the heating and ventilation through the air conditioners are done as such. So if you take any air conditioner, if you see the let us say around 2 kilowatt per ton it takes for the running ton, almost the supply air fan, the air handling circuits, they consume around 21%. Then the pump consumes around 8%. Then the compressor, the HVAC compressor consumes around 54%. And the pumps, the primary and the secondary pumps, they consume around 8%. And the cooling tower, that consumes around 8%. So this is where, like the Pareto principle, what are all the small systems are there, subsystems, if they are operated smoothly and if they are operated efficiently, the compressor run hours also can come down. This is where each and every industry or the building management systems are working on how to reduce the compressor run hours, how to make the compressor loading efficiently run during that run hours time. You can see the difference on a conventional design and the optimized design. And the improvement potential is for the chiller, for the air distribution, and for the water pump, and for the cooling tower. You can see so much of almost 65% the improvement potential is possible, especially on a HVAC system, and that is what is happening now. I will suggest you can visit to any of the green buildings in our area, in where our college is there. You can find the difference, so much of difference is happening here. The first point which I was referring to, the air circulation consumes only 10 watts per square meter, whereas the air cooling, it needs around 40 watts, whereas an air conditioning, it takes around 200 watts per square meter. This is where the air circulation is getting superimposed on an air conditioner, and especially thanks to the BLDC or the brushless DC fans, where the mild circulation of air inside the premises, inside a room or inside the area or inside a hall, definitely the heat load is maintained there, and also the air is well circulated, so that the evaporation loss that is coming across the human body, that is also removed, and ultimately the circulation gains more importance than the air conditioning now. This is the condition now, and lot of the government has already made a mandate for 24 degrees, and many of the industries and buildings are operating at 27 degrees also within the air conditioning, in the air conditioned premises, and they are able to see the human comfort excellent as such. The BLDC fan versus the old fans, we are all aware, but the main point which we always focus is, any of the fans are never it runs at full speed, and when you run it middle speed, say if you see around second speed or third speed, it around 6 to 11 watts only. This is where especially the domestic people, where they have inverters, they have switched over to the BLDC fan. Their inverters backup time, it almost gets doubled. This is how the BLDC fan in VA and watts, both way, it is a huge savings for us as such. This attic ventilation, this high volume low speed fans, this is taking up in a green building areas or any of the building where the infrastructure areas where we are concentrating more. It costs only few thousands, but it gives a lakhs of CFM cubic feet per minute flow at a very less static Pascal, so that it keeps the see, if you see the place like Chennai, around the evening, around 2 o'clock or 3 o'clock, you see a breeze, no? That breeze is possible with this type of HVLS fans, vertically mounted. And this is a horizontally mounted HVLS fans. In many of the commercial buildings, they have started installing it. They are able to achieve the wind chilling effect inside, and ultimately it is able to replace many of the hundreds and hundreds of ceiling fans. And many of the industries, many of the buildings have gone for this HVLS fans, and it is a welcome trend. If you go to Central Railway also, in the Central Railway station, the waiting room, you can find so many these HVLS fans are running, and the place is so cool even compared to the ordinary existing man circulator fan. This is giving a better job as such. Let us understand what is the natural ventilation, the effective schemes of natural ventilation. This is more important. To combat the climate change within the premises, or within, see, if you want to take a pathway towards the climate change, these are all the areas where the air circulation, the natural circulation and the forced circulation, how this needs to be done. The hot air always coming from the top, and it has to see, you can see the what is the wrong ones and what is the right things to be done, and you can see the difference, and how the positive cross ventilation of the given premises to be done in such a way that you always feel the a place where the breeze of air, cool air inside the premises, the occupants who are working in the industry. Coming to the demand controlled ventilation, this is where the IT buildings and many of the, where let us say around 1000 seats or 2000 seats or 500 seats, many of the seats where the humans are occupied, the carbon monoxide and the carbon dioxide sensing. See, we are not talking about the oxygen sensing because it is a trace, but we talk in terms of CO2 measurement or in terms of CO measurement. In CT, that a fully open damper at the fresh air or a partially open, see, based on the load, this can be adjusted. You CT at that the CO2 measurement is a critical parameter, especially in many of the buildings, closed buildings, essentially. You can see almost 1000 ppm. See, 1000 ppm is the CO2 ppm to be maintained ideal. And where our buildings stand, I don't say in the college, but college it's all well ventilated. But if we take a case of IT buildings or any closed buildings, The CO2 measurement and CO2 monitoring and CO2 control, the over ventilation or under ventilation. We need to see to it that you have ideal ventilation, and under ventilation is what there in 10, say 7 out of 10 cases it is only under ventilation. People are suffering due to medical problems due to under ventilation. So it needs to be ideal or slightly over ventilation also to have a CO2 ppm measured values around 1000, 900 to 1000, 900 to say precisely. So for the green building, it is not only the energy efficiency, it plays a catalytic role, but we can see the water efficiency, better living conditions, sustainable materials, transport use, and the wastage, the habitat protection. That is more important. See, the government has given a lot of missions where the energy mission, energy efficiency mission, then the water mission, the solar mission, all these things. Ultimately, the green building, it is covering all the other aspects and can play a major catalytic role towards addressing the ESG parameters for any of the organization as such. So the building design, the envelope, all the glass, all the appliances, all the lightings, all the renewable, all the energy monitoring. You can see the high performance walls and roofs, the fly ash bricks for the walls and overdeck insulation. We have underdeck insulation and overdeck insulation. You see that the solar is not getting ingressed inside the building, so we have the both overdeck insulation as well as the underdeck insulation. In CT that we are trying to maintain the heat that is emitted from the solar to the building is less. Then the high performance glass or the low E glass, low emissivity glass, that's what we were discussing before. And the star rated appliances for all the air conditioners, refrigerators, geysers and other things. Lightings we have already switched over to LED, and for renewable energy also you see what is the efficient solar rooftop solar that is available in the market, and go for that as such. And everything and everywhere, Bureau of Energy Efficiency has said only one thing: monitor your energy consumption, say from a 3 HP or a 5 HP machine, motor or a machine or anywhere on a 3-phase circuit, and then only you can take the control, and then you can monitor it and target the control towards that. Water management, though rainwater harvesting is said and done, again it needs to be done scientifically done as such. The sourcing of building materials also, it is done eco-friendly materials, and that too it is from the nearby buildings only. The certified wood, the green wood or the certified wood that is also used from the local forestry, that also matters more here. The sustainable site measures, this is where we are concentrating more as such. And the transportation, where we can go for a EV type, alternate fuel vehicles and other things. So the landscaping is important, the irrigation efficiency, going for the agriculture has given us a lot of inputs towards drip and sprinkler irrigation, we are making use of it. And the interior finishing materials, you see that volatile organic compound is avoided in paints and adhesives, etc. And ventilation and daylighting, we are giving more of importance here. Views from the occupants, the views is more important because that is also making an aesthetic sense as such. As I was telling before, the light roofing or you can see the white roofing that is done on a conventional roof at 80 degrees, on a cool roof it is around 50 degrees, and the ambient temperature drops by 7 degrees. This is going to become mandatory in a short while, and many of the government buildings, office buildings, commercial buildings and residential buildings, they need to go for this type of white roofing, their open terraces as such. It gives an excellent savings. The solar reflective index is more measured, that is a measure of emittance and reflectance, that is more important here. The performance of cool roofs, that is more addressed here as such. And again, the buildings which are going for commercial, all these IT buildings, many of the people, they go for green roofs than the conventional roofs, traditional roofs. The green roofs, the intensive green roofs, they have a deeper soil and large plants, they make it as a roof garden, and see to it that the heat ingress from the solar is very much brought down whenever in coming to the different floors underneath the top open terrace as such. Coming to the water side, the government has made a gazetted notice for all the government buildings, office buildings, around these aerators to be used in any of their water taps in all the buildings. From almost it saves around 70% of water, so especially on the cleaning application and especially on the water taps. The restrictor and aerator is becoming a mandatory for any of the colleges, for any of the public institutions, for any of the office buildings as well as. So the building management analytics as well as the BEMS, they are basically based on statistical analysis, but still BEMS has to go in together. The BEMS has to be embedded in the BM analytics, so that the existing old buildings, they can go for this BM analytics, but can be incorporated with the BEMS, and the potential for payback is not 5 years, it has come down as such, because lot of IoT based mechanisms have come on the usage side, and lot of savings are possible based on the usage side as such. Coming to this, these are all the areas towards the building side. I am just concentrating on the industry side, where the industry wants the energy conservation plants to improve their cost competitiveness, to have a cleaner environment, for the natural protection of resources, and ultimately the technology improvements, the process improvements or the technology improvement. These are all the areas deliverables by an energy audit and conservation that is regularly done, routinely done by a given industry. If you see, go by the nameplate of any of the equipment. See, when you from the college also used to visit the industries, you can see what are all the nameplate for the given machine, for the given motor, or for the pump or a blower or a compressor, whatever it may be. What does the nameplate say? What is the efficiency as per the nameplate, and what is the efficiency as per the latest energy efficient machines nameplate? These are all the benchmarks. We go by the benchmarks and how this can be addressed upon. Ultimately, each and every company, they see the energy cost is affecting the company's profitability, competitiveness, and they are not able to compete with the local and global environment. All these things are important. See, once the energy audit is given the focus and the priority, and lot of in-depth study and implementation is done, many of these factors, either on the productivity side or the quality side, and even on the loss prevention and wastage dispersal reduction, everything can be addressed upon thanks to the energy audit and conservation to be done routinely and passionately by the industry. See, if you see why the energy audit or the energy consumption is happening for a given industrial process, the industrial process has energy, water, chemical, raw material, everything is there. But if it is consuming more, let us say your fridge consumed 3 units per day, the previous fridge, that is a 1-star rated fridge, the latest fridge only consumes 1 unit per day. I am just telling a domestic angle, because, or you can take a 4-wheeler or a 2-wheeler, watch, it was giving around 20 to 30 kilometers per liter, now it is almost 50 to 60 kilometers per liter on a 2-wheeler. See, these are all the areas. The equipment or the process gets damaged inside when excess of inputs are given. So, and the emission is also more. So, optimize the inputs, the products will improve, and the liquid and waste, solid waste also comes down, direct and indirect waste also comes down as such. So, routinely visit whenever when we go for the energy audit study for a given industry, what are all the production machines, how they are, the wetted parts are there, how this can be restored back. For your example, the supercritical thermal stations, they had a big study, and they said when we are able to replace the wetted parts inside the thermal stations, we can achieve from 40, see, it was around 40% means the efficiency of the supercritical thermal station, they can even raise it to 45%. 5% they are 5 to 7% they say by removing the replacing the wetted parts inside the turbines and this one, the thermostation systems as such. The utilities, if you see the end-to-end output parameters, that will decide where is the loss going on the distribution side. Whatever you say, the T&D loss, if you say around 20%, 5% only goes towards the transmission loss, and the 15% goes towards the distribution side. Thanks to our Tamil Nadu's latest this one, it's around 10% now on the T&D side, our loss, ATC loss in Tamil Nadu. But throughout the India, what all it is told by our Dr. Beloved APJ, around 20%, now we wanted to reduce it gradually to 15% to 10%. What all the China or Japan or say China or Germany, they achieved around 4 to 7% their T&D loss. Why not we also achieve it? So it is possible as such. The end-to-end loss, this is what we are concentrating in the industries also. If it is a compressor utility means we concentrate on generation, distribution and usage, and then fans means we concentrate on generation, distribution and usage, and the static Pascal. this is more important, the static Pascal. You can see a difference between a BLDC fan and an ordinary ceiling fan. The static Pascal is more in an ordinary fan, and what the humans need is one is enough is a BLDC fan. This is what the underground or the told truth that needs to be understood as such. The same thing happens with pumps or HVAC or the boiler distribution, steam distribution end to end as such. Always when you visit an industry, first what is your EB input hertz and what is the RPM of all the machines. It is a easily measurable, non-invasive type, optical type. This one is there. RPM meters are there. Stroboscopes are there. You can measure all the machine motors. You can see what is the production loss or the utilities for the given industry as such. So coming to the energy audit, what is given as an energy input for the given system or an equipment or a machine? What is the useful output, how to increase the useful output and how to reduce the wasted output. This is the working or the procedure of energy audit what we follow in the industry. Let us say it's a 40 watt tube light with 15 watts choke. Now it is brought to a 15 watt choke is removed, this tube light is removed, and first they brought it with LED, that is electronic choke that reduced from 15 watts to 2 watts. That is, and the 50 hertz operation of lighting, it was taken to 20 kilohertz, especially the lighting. Automatically luminous intensity also improved by 15%. So a typical case study from a fluorescence tube to LED, and automatically this stands well. Not only for the LED, you apply it for the pump, you apply it for any other machine. You see what is the useful output, how to improve the useful output, how to reduce the wasted output. This is the procedure in energy audits. Coming to when you enter the industry, there are three types of machines. One is constant torque machines, constant speed machines, then variable torque machines. This is how we classify for any industry. All the production machines invariably they become constant torque machines, and all the utilities, especially the centrifugal blowers and compressors, they become variable torque machines. The scope for energy saving is more in a variable torque machines, because ultimately the motor power, it is directly related to the power, the torque and speed. If you are able to manipulate the torque, what is the demanded by the load, and if you are able to adjust through the VFD, you can adjust the torque, you can adjust the speed, and definitely you can achieve a savings. I'll just come to you on that case study also. Thanks to the latest international energy regulations, IE1 to IE2 to IE3 to IE4 and IE5 also has come in the market now, and the government has mandated from 2018 onwards, the companies, OEMs as well as the running user companies, they need to go a minimum standard IE2 efficiency, then they have to go for IE3 motors as such. The RPM gain on each and every version is more as such. That is how the production also goes up more as such. You can see the initial cost to running cost, almost 99% the running cost goes towards the power. So always pick up the best possible, best efficient motor that is possible. The IE5 motors, see again, the induction motors, that is what we have studied, and the permanent magnet synchronous motor. This is it is a change. Say from CFL to LED is a big change. CFL or a Gundu bulb, or you can say the glass GLS bulb, it gave more of heat, whereas a LED it gave more of light. Like that, the induction motors are of a different concept, whereas a permanent magnet or a synchronous motors are of different concept, where the efficiency is almost steady in a permanent magnet synchronous motors. But it is still in the nascent stage. It has to come up in a big way. The pricing have to come down as such. But now many of the industries have gone for IE2 to IE3 motors, and they are already changing it now as such. For any of the Bureau of Energy Efficiency has given lot of inputs, especially they have clarified only 4 steps. Wherever possible for a given industry, as I said before, instead of giving a 240 volt to your LED tube light, you just give 200 volt. Instead of giving a 415 or 440 volt to your motor, you just operate your motor which is only 3/4 loaded, you just operate it 400 volt. Trimming the input side, that is the low cost, zero cost exercise, and it is possible. And accurate monitoring is first step, the monitoring of the power, kilowatt and kVA for a given equipment, and then the trimming of the inputs, energy inputs. The third step is whatever the equipment is getting, say let us say the compressor is running, lot of heat is wasted through the exhaust. how this can be retraced, how this can be recovered, how this can be put to use as such. When I worked in a user group, Dutch, group, they said, Holland, they said, we are not allowed to waste the water which is more than 40 degrees centigrade as a effluent from the industry. Whereas we in our place, we are wasting more than 60 to 70 degrees of hot water is getting wasted as effluent. So the trapping or recovering the heat that is there embedded in the system, ultimately the MCP delta T plays a major role, and the heat that is embedded in the water that is getting wasted, that needs to be retrieved. This is where we are concentrating more now, and recycling wherever it is possible, over and over again. What I was telling you before, and this is the case study where it shows, and it is, we have seen in many of the industries almost around, you can see when operating at 400 volts and when operating at 440 volts, around 10% savings, around 5% savings on the motor, and for the lighting, especially for the previous HID type lightings, it was around 10%, but for the LED now it's around 5% only. See, high intensity discharge tube lights, especially the fluorescent tube lights, they had a lot of savings, but not on the LED, but LED also gives a savings of around 5%. This we have seen through our case studies in our industry. Thermal imaging, see, whenever the college professors, when you visit a industry, you go with a thermal imager, you go with a stroboscope. The industry welcomes you with a rose garland because they don't know what is happening inside the system. This predictive monitoring through thermal imaging, you can throw a lot of inputs to them. It is a win-win situation for the college as well as for the industry. Thermal imaging, infrared thermal imaging, it is a mandatory tool for any of the routine maintenance people in the industry now. Even for MSME, they are trying to buy it now because it was costing many lakhs before. Now it has come to less than 50K only. Micro level monitoring of all the equipments and macro level analysis. This is what is needed by the college and academic and industry interactions as such. This is what is seen through the thermal infrared thermal imaging. What is the temperature of the motor at 3, 6, 9 and 12 positions? 3 and 9, it should be less than 20 degrees, or 6 and 12, it should be less than 20 degrees, and driven to non-driven, it should be less than 20 degrees. See, these are all the areas where you see the thermal imaging shows the hot spot as the loss towards the motor's health. See, a motor is talked about the thermal, see the GD squared value for the given the load that is coupled to the motor, whereas the motor's thermal health depends upon the temperature rise in the given motor, and the motor is warm means it is good. If the motor is hot means it is losing its energy, it is running inefficiently. If the motor is cold, it's just idling means it is losing more power than the warm motor as such. Here I will suggest the institutions can play a major role, especially the academics. You can see any of the equipment before the failure begins, let us say proactive and predictive and fault domain. You can see the ultrasound monitoring, you can see the vibration monitoring, you can see the vibration in acceleration due to gravity and per second. All the displacement as well as the acceleration, everything is possible to be measured with a single plug and play probes now. These are all used by many of the college or academic professionals in the industry now. Ultrasonic measurement, especially for the pumps, it is more critical now, and we are see the industry is struggling now to know what is the pump flow rate. This ultrasonic flow machine from the college to the industry, they all will be very happy. Oil analysis, what is the oil? Carbonization of the oil is more important. Then comes the infrared. If you see, the infrared imaging is almost at the tail end of the failure. Then comes the audible noise from a given motor or machine, then the machine becomes very hard to touch and fails already. So you have a scope towards ultrasound, vibration analysis, oil analysis from the mechanical department, infrared analysis from both electrical and mechanical department. You can do wonders in the industry by your non-predictive operated, non-invasive type portable instruments. This it was costing more than 10 lakhs before, it has come to less than few lakhs now as such. Each and every college is supposed to have these type of portable audit tools to assess the machine's health and the process health as such. So I was telling you that the T&D loss from 20%, it has to be brought down. What the nation or the national grid is working, the government is working on that, but we from the industry, we can optimize the end-to-end energy loss. It should be less than 10% or it should be less than 5%. We see it, the industry has the end-to-end energy loss is less than 5%. It can be on the piping side, it can be on the ducting side, or it can be on the fan side also. I'm just going in depth on a blower, this one. A blower, normally a motor we say around 80% efficient or 90% efficient. If you see the blower's efficiency is around 56%, you can see the efficiency is only 56%, system efficiency. See, the scope for energy saving in blowers, pumps and compressors is very much more than in motor. This is the idea or the main fulcrum where the energy auditors we are working on that. We are working on the load side of any of the system, subsystem, utility and auxiliaries. Wherever we are able to put our hands, we are trying to manage and we are able to measure this, and we measure the volume flow, we measure the Pascal with the digital, everything we have made digital measurements. Thanks to the digitization and IoT monitoring, we are able to see a lot of inputs, the wrongness that is happening in the machines or in the process. This is what I was telling you. A typical electrical, what we see, a motor means it gives a definite torque, fixed torque and the fixed RPM and all. See, here by a combination of a VFD and just operating the belt and pulley to a different size, see ultimately you can see it is an air handling unit motor. Done in a Danfoss unit in Chennai. Basically, they are VFD majors, OEMs, but they are also surprised to see we are able to keep in the case study, the blower RPM is fixed around 860 before, and at 50 Hertz, and at 33 Hertz it around 550 Hertz, 550 RPM. But the energy savings achieved by just the belts and pulley changes for a given motor to blower, that gave around 10%, and the VFD by the voltage reduction, they are able to, it gives around 10%. Around 22% savings is possible at a cost of less than 20,000 only. And people are going for energy, electronically commutated fans, spending around 4 lakhs or 5 lakhs. But when you spend around 20,000 on your air, see, you can see in your college also, many of the air handling system AHU units are there. You just see the circulation systems, you just try to replace this and just, not the replacement, retrofit this, and you see the 20% saving. This will be a case study for your students, for your next generation as well. This is what I said. This is an area throughout the world, throughout India. In fact, our energy audits and the case studies after implemented after the audits, it has given a big scope that the curve what you see, the variable torque versus the variable power, that is the, you can see at 50% of load there is a gap. That gap is addressed by the VFD. By facilitating the VFD, the load needs lower torque only, especially the blowers at lower speeds. If the VFD is made to facilitate it to address it at the lower torque, definitely that 15% savings is there on the existing motor. See, this is where a VFD coupled motor along with this pulley and belt combination gives around 15 to 20%. This is a cakewalk by the many of the IT buildings, and many of the buildings are doing it now instead of going for a EC fans now. EC fans is very costly. It is a proven product. But the cost is so high, it is 10 times the cost of the existing retrofit. That needs to come down. In the case of pumps, see, around 70-80% is possible, whereas the old system efficiency around 31%, the new efficiency is around 70%. You can see the difference. The difference is coming at not only at the motor end, at the coupling, at the pumps and at the throttling efficiency, everywhere. Ultimately, 40% the scope is there, especially in the replacement of pumps and the piping systems. We don't say pipings to be replaced, but see to it that the efficiency can be improved upon here. You can see the 5-star rated pumps. What is the difference when the agriculture farmer has understood, let us go for rigid PVC pipes, but many of the industries still they are using this MSERW pipes or the GI pipes, where there is around 20% loss is there due to the pipe friction. See, water has a surface tension and the pipe has a pipe friction. Both make to see to it that the velocity of the water flow to the overhead tank gets dropped automatically. And here you can see the savings by going for rigid PVC pipes. These are all the way the piping needs to be done. It is not the pump alone replacement. A pump is having a flange of 3 inches, means the piping or the header should be around 4 inches or 5 inches or 6 inches. Almost make a slow entry and make a fast output. That is what the traffic sense has told us. Any bend in a traffic on a road, go enter slowly and come out fast. This is what the universally applied this one. The rotators need to be small and the conductors need to be big. These are all the universal thumb rules which we try to apply in each and every energy audit case study for the given industry. When the pump is replaced, to showcase to your students, you can say, when you spend around 20,000 rupees, you get around 7,200 rupees per year, almost 36%. This type of interest nowhere you can get, only you get in terms of metered vaddi or kandu vaddi. That is not possible. But in the technical area, around the replacement of pumps, especially the old to new generation pumps, around, you can see the savings, around 36% the energy savings is possible. This is what we have to capitalize. First, let us measure what is the pump delivery, what is the pump nameplate is, what is the delivered water at the overhead tank in our college overhead tank or in the any of the premises, and where we stand, what is the difference and how to address that. These are all the small pet projects you can take it up as it. And from a single monoblock from a multi monoblock, that gives another savings around 15%. To make a NPSH, net positive suction head, is maintained using this multi-stage monoblock pumps. Coming to the compressor, compressed air, whenever you go to industry, concentrate on compressor. It is a dynamic variable. It is a utility only, but it is a dynamic moving variable where you can see the pulsations of the compressed air flow and pressure at the bottom. It is almost zigzag based on, see, it is rated for a given process, but the process does not need that much of flow. So this needs to have a edge technology based IoT monitoring, and that needs to be a very much see, this needs to be promoted in the industry. Industry has not installed still now flow meters and all. They need to install the flow meter, especially for the compressors, compressed air, and it is not an instant measurement, it is a trended measurement which is made computer compatible, and it will give lot of inputs to the industry, lot of inputs to the academics. What is the thermodynamic equilibrium for the given compressor? What is the isometric efficiency of the given compressor? All these things can be studied here. So an energy audit, not only for the building, I said around 15 to 20%, for the industry also, housekeeping itself can give around 5 to 10%, minor investment around 10 to 15%, and regional investment around 20 to 25%. These are all the tools we are using, and power quality analyzer, because power quality is definitely made to mandatory now. Even our inverter compressor or inverter fridge, that is having so much of harmonics, H7 and H5 and H7, especially on a 3-phase systems, especially on the industry, this is creating a havoc now as such. And the this one, instant clamp-on power meters, then the thermal imagers, then the anemometers and the static Pascal meters, etc. So this is, if you view from the academic side, thanks to your the respected professors are giving this opportunity to share my thought process. The academics can make a big way inside the industry, provided you have basic instruments like this. I'll just give all the pricing details also of all these instruments. It can be less than a lakh or it can be more than a lakh also, but whichever you see, a person visiting an industry, but along with the meters, this makes more sense, and the industry wants only the people with who can take readings of their own hotspots or the measurements or the electrical inputs or the process measurements. They are more interested in that. We can definitely make it will be a win-win situation for the academics, for the college people, for the college professors and the team to visit each and every MSME, because MSME cannot afford to buy all these tools and tackles. We can definitely give a big way to the industry and give a lot of inputs to the industry. Your support is very much needed in the industry. So ultimately the industry or the Bureau of Energy Efficiency says improved energy performance means it is not the making the efficient equipment energy efficient. Also, instead of running for 4 hours, we can run it for reduced operating hours. You can run it for 3 hours. This is where we are trying to achieve either on the time baseline or on the baseline energy use. both of energy savings is possible with respect to time or with respect to energy. So the pumps around 30 to 40%, the 5-star rated pump around 70 to 80%, compressor around 4 to 5 CFM, whereas 78, see, almost doubled. If we see the blowers around 30 to 40%, it is around 80. See, these are all the areas, the gap between the efficiency of the existing machine or the utility and the efficiency of the new utility, energy efficient utility is around 40%. We can very much address the gap and see to it that the industry, I don't say they have to replace totally. First, let us make them understand you run the machine energy efficient loading and try to achieve with minimum loss. If that is not possible, go for replacement. Thanks for giving this opportunity, and I will be happy to receive many questions from your end. Thank you all. Hello.
Participants, you can ask your doubts. Any questions from participants?
It can be from the participants or it can be from the college team also. I'll be very happy to share my.
Whoever want to ask, please raise your hand. The mic will be given to you. Sir, one question from my side.
Please, ma'am.
As a BEE accredited energy auditor, how do you see the effectiveness of current government policies on energy conservation? What improvements would you suggest?
Ma'am, you have asked a very right and timely question now. In fact, many of the government schemes now it is aligned to the energy conservation because they are operating on two-pronged strategy. One is on the solar renewable. That needs to be definitely be ramped up. But also this energy conservation and energy efficiency, they are giving a big scheme like Aditi scheme or P scheme by the state government and the central government. And lot of industries are making use of it. They give priority and thrust towards the energy conservation. Now, the government or the Bureau of Energy Efficiency as well as the industry, they have understood the shortcut towards energy saving is only energy conservation. And if you want to pay more, then you can go for renewable. So everyone has understood, and the government is chalking out lot of new schemes, Aditi scheme, this P scheme, and lot of the banks, Sidbi Bank, and many of the banks are also giving towards the energy efficiency deployment in the industry. So the energy conservation is going to take up in a big way. And why I am telling this is the World Bank projects where we have done that, and many of the SAARC countries throughout the other than India, all the energy prices throughout the world has gone up. In India, it is still subsidized, I should say. And definitely for this price, the industry or the government wants the industry to definitely reduce or optimize their energy consumption. That is what it is needed by the government, and the industry is towing in line with the government directives. Only thing it needs to be enforced. That's what we are all expecting as such. Thank you, ma'am.
Yes, sir, definitely, sir. Sir, with the shift towards IE3, you told no, sir, for efficiency of motor from IE3 to IE4 and 5-star rated equipment. How do you suggest companies plan for equipment replacement versus repair?
Normally, if the company is having let us say a single motor, it is operated for more than 20 hours a day, and it is already overloaded, and it is 3 or 4 times rewounded, then we will say it is a fit case of replacement. If they say, let us say if you have in your college, you run the pump for only 2 hours a day, that need not he have a replacement now. The more hours of day, more of running hours per day, and more times rewinding done, or more inefficient loading, like it is overloaded or it is totally undersized or oversized motor, that needs replacement. And government has mandated already all the industries they should go for only IE2 motors, but it is still happening in a slow way only. Everything, see, one is they say always it is carrot and stick. If you always give carrot, they always take the carrot only. So if you have both carrot and stick, definitely they go for the stick. And see, the enforcement needs to be there. Definitely the industry will go for this as such. But lot of inputs and concessions have been given to the MSME, this one industry, to go for this latest energy efficient, this one is incentive and the subsidy, and a lot of for energy audits also lot of subsidy, and energy this implementation also almost around 10 lakh subsidy is given by the state government and by the central government also through the Aditi scheme as such. And the industries who are all willing to take up, they are very much taking it up. And many of the industries, they are technically not aware of it, that we are trying to educate them. Let us like say consistently educate to collectively conserve as such.
That is very important, sir. We have to educate the industries also.
Exactly.
Sir, in the level of students,
Yeah.
the who are all beginners, who are all entering the energy field, what skills and tools
Yeah.
should they focus on mastering for successful careers, sir?
Uh, the skills
Oh,
what they need is, I will always say for any of the college students, what all the equipments that is used in the college or in at home, let us first study it. And thanks to trivector meter that is deployed by the EB, by most of the say out of 1,000 students, almost 900 students, they have this trivector meter. First, let them monitor their energy consumption with respect to the nameplate. They know where we stand. That is, whether they are energy efficient or inefficient, whether the consumption is as per the nameplate. Automatically, that will prompt them to take up more energy conservation case studies in their house or in the college. That is why we also suggest the colleges showcase to your students what a BLDC or what a ordinary induction fan does, what an IE5 motor does, what a permanent magnet synchronous motor versus induction. See, up to IE4, this induction motor is only there, where the efficiency curve is around flat, more than from 45 to 95, say almost 100, the IE3 and IE4 and all, they are having a flattish curve. These can be very much studied in the college itself. And we need some equipments, basic equipments like a stroboscope to measure the RPM. See, RPM is the area where many of the industries they have noted now. They find so much of RPM change. A previous motor around 5 HP motor, it was giving only 1450 RPM. A new 4-pole motor, it gives almost 1480 RPM. 30 revolutions per minute they are gaining by replacing one motor. So this is the area which we say showcase to the students what are all the deliverables, what are all the facilities, or what are all the additional benefits we get by going for this IE3, IE2 and IE4 motors and all.
okay, sir.
Thank you, ma'am.
Okay, sir. So nowadays, most of the people all are using the smart appliances and IoT devices.
Yeah.
So how do you see the future of energy monitoring at the consumer level, which will evolve?
Definitely, ma'am. In fact, many of my energy professionals, they are sharing the smart application, smart EB monitoring. Everything has been done in the Western countries. In fact, it is slow in India, but definitely this IoT based mechanism, because for the usage efficiency, the IoT based mechanisms, they are prompting the end user to curtail their energy. So the IoT based mechanisms is going to stand not only for the industry, very much for the buildings also, and lot of scope is there. IoT based, see, the a typical example is EEPROM based this controller, embedded controller, what we are using for a ordinary AC, the split AC, non-inverter AC, it gave around almost 20 to 25% savings. This EEPROM based motor, this aircon saver we say, and these are all the areas the students can themselves can see. Many of the new startups, they have come with lot of IoT based this one to address to the stomach ache of the given industry, and they give lot of timely solutions. Industry is very much taking it as such.
Thank you, sir. Thank you for clearing our doubts.
Thank you,
Yeah,
ma'am.
participants, can you ask any doubts? Any doubts from audience? If there no doubts means shall we uh, wind up, sir?
Yes, ma'am. Thank you, ma'am.
It is
Thank
my privilege to show my gratitude for today's enlightening session. On behalf of SESVMB, I extend my heartfelt gratitude to Engineer Ashok Sethuraman, sir, BEE
Thank you,
accredited energy auditor, for sharing his deep knowledge and practical insights on energy efficiency in building and industries. Sir, your talk highlighted how energy conservation is not just a necessity, but the most cost effective way of power generation. From simple measures like efficient lighting and fans to advanced technologies like VFDs, thermal imaging, and predictive maintenance, your presentation showed us how small changes lead to big savings. We are especially inspired by case studies and real world examples you shared, which made us realize that energy efficiency is achievable, practical, and beneficial for both industry and society. Your emphasis on sustainability, monitoring practices, and the role of young engineers has given us a clear direction on how we can contribute to a greener future. We thank you, sir, for not only sharing your expertise, but also motivating us to act responsibly as energy conscious citizens. I also thank our respected management for giving us this opportunity and all participants for their enthusiastic presence. Once again, thank you, Ashok sir, for your valuable time and inspiring session.
I sincerely thank you, ma'am. I sincerely
Energy,
thank you, the
energy
respected
saving is
professors.
energy generated.
Yeah,
Today,
exactly.
you have shown us how true this is.
Thank you, ma'am. Thank you, ma'am. I sincerely thank you for the respected professors and for giving. See, we are learning from you. In fact, we are relearning from you even at this stage and age. And we wanted to share to the college academics and the faculties and the students. And I am very much available to you. Anytime you can definitely call us for more of case studies, practical case studies, which I will share in our WhatsApp group also in our college. This one also. Thank you, ma'am. Thank you, ma'am.
Thank you, sir.
Thank you.
Thank you,
We
sir.
will be touch in future also, sir.